Hello everyone, myself Hans. Today we are going to solve the problem of partial differential equation. Here in the question, find the partial differential equation of all planes which are at constant distance k units from the origin. Let's solve the problem. First we have to know that equation of plane having constant distance k from the origin. This is given by Lx plus My plus Nz is equal to k. This is the equation of plane having constant distance k from the origin. Let this is equation 1. And we have to know that the equation of plane normal to the given plane is, we know that this is L square plus of M square plus of N square is equal to 1. And let this equation 2. And from here we have to further, we can differentiating equation 1 with respect to x and y. We get, first we have to differentiating with respect to x. This gives L plus of M, and this is dy upon dx, and plus of N, this is given by del z upon del x is equal to 0. K is the constant, and we know that here we have to denote the partial derivatives, which is del y upon del x, and we know that del y upon del x is given by P and del z upon del x is given by Q. So we have to write here, this is L plus of MP, and once again this is M differentiating with respect to x. This is del y upon del x, and this is the function of xy. So we have to take in z is also constant. So from here, this portion is also 0. We get this is 0, and this is L plus MP is equal to 0, and from here we have to get L is equal to minus of MP, and from here equation 1 partially differentiating with respect to y, this gives y, this is given by, once again differentiating y, taking here x as a constant. So this gives M plus of N, this is del z upon del y, and this is equal to 0, and from here del z upon del y is given by, once again this is del z upon del y. Del z upon del y is given by Q. So we have to write here M plus NQ is equal to 0, and from here we get M is equal to minus of NQ, and we have to put the value of L and M in equation 2. Putting the value of L, M in equation 2. Putting here in place of L, this is given by M square into P square, and in place of M here this is N square into Q square, and here is N square is already present, N square is equal to 1, and from here we have to take in once again del M square P square. This is L. Sorry, when we have to differentiating with respect to x, taking y as a constant, we have to write some mistake here. This is given by del z upon del x is p, and del z upon del y is q. The equation 1, partially differentiating with respect to x, taking y as a constant. So we have to get here, this is L differentiating x with respect to x, this gives 1, and my is taking constant, so we get 0, and here is nz. So we have to get here, this is n, and this is once again this is n del z upon del x. So we have to put here in place of del z upon del x, this is p. So we have to write in here, this gives L is equal to minus of np, and further we have to equation 1 differentiating with respect to y, taking x as a constant, we get m plus n into del z upon del y, and del z upon del y is given by q. So we have to write here m is equal to minus of nq. So from here this is n square, and from here taking n square is common, this gives p square plus of q square plus of 1 is equal to 1, and from here we can also write this is n square is equal to 1 upon of p square plus of q square plus of 1, and we can also write here this is n is equal to under root of, this is 1 upon p square plus of q square plus of 1 to the power 1 by 2. This is the value of n, and further we have to put here, we have to get L is equal to minus of np and m is equal to minus of nq. So we have to put the value of n here first. We have to put in, this gives L is equal to, in place of n we have to put in the value 1 upon, we can also write this is p square plus of q square plus of 1 to the power minus of 1 by 2. Taking p square plus q square plus 1 into numerator, we get the result, and here we have to put the value here, this is minus of p square plus of q square plus of 1 to the power minus of 1 by 2, and here is multiplication in p, and we can also put in the value of m. This gives m is equal to minus of here p square plus of q square plus of 1 to the power of minus of 1 by 2, and here is multiplication with q, and further we have to put the value of L and m in equation 1. L and m in equation 1, we get the required result. Once again we have to put in, the value, this gives, in place of L we have to put in here, this is minus of p square plus of q square plus of 1 to the power minus 1 by 2, and here is into px plus of, here we can also put the value of m. This is given by minus, so we have to write here minus of p square plus of q square plus of 1 to the power minus 1 by 2 into y, and here is q. So we have to write here qi, and in place of n One second, we can also put the value of n here. This gives plus of n is given by p square plus of q square plus of 1 to the power minus 1 by 2 into z is equal to k. And further we have to simplify, we get the required partial differential equation. We can write, once again, we have to write in, this is minus, first we have to multiply minus with both the sides. This gives, we get the plus, and this is given by p square plus of q square plus of 1 to the power minus 1 by 2 into px plus of p square plus of q square plus of 1 to the power minus 1 by 2 into qy, and here is minus of p square plus of q square plus of 1 to the power minus 1 by 2 into z, and here is minus of k. And we can also eliminate k. Once again, we can put the value of k here, and further we can also write, this is taking p square plus of q square plus of 1 to the power minus 1 by 2 into denominator. This gives px upon p square plus of q square plus of 1 to the power 1 by 2, and plus of here qy upon p square plus of q square plus of 1 to the power 1 by 2, and here is minus of z upon p square plus of q square plus of 1 to the power 1 by 2 is equal to minus of k. And here is taking LCM. LCM are, here LCM is p square plus of q square plus of 1 to the power 1 by 2, and taking cross multiplication with minus k, this gives px plus of qy and minus of z is equal to minus of k into p square plus of q square plus of 1 to the power of 1 by 2, and we can take minus of k into p square plus q square plus 1 to the power 1 by 2 into left hand side, we get the required result. This is given by px plus of qy minus of z and plus of k into p square plus of q square plus of 1 to the power 1 by 2 is equal to 0. This is the required partial differential equation of the plane which are at constant distance k units from the origin. Thank you class, and thank you for watching.